Okay, so this is problem 6.8 out of Griffiths Introduction to Quantum Mechanics, edition 3. And if you wouldn't mind, please like and subscribe. It helps me out, and then you'll be able to see all the videos I upload. Okay, so part A says, show that the parity operator is Hermitian. So again, the parity operator, acting on some state psi, changes psi of x to psi of minus x. That's what the parity operator does. Okay, so is it Hermitian? Well, we can define an operator to be Hermitian, in this case the parity operator, if it can be written like this. So can we do that? Well, let's see. We know what parity is going to do on g of x. That'll simply make that g of minus x. Okay. And what we can do is a substitution where we let x prime equal minus x, or x equal negative x prime. It's just a dummy variable, so it doesn't actually matter what you call it. So if we do that, then we have f of minus x prime, g of x prime. But this part, that's just parity operating on f of x prime. So we were able to successfully write it. One thing that kind of tripped me up a little bit is we're comparing x to x prime, but our professor said that it's just a dummy variable, so it doesn't actually matter. So that shows that it's Hermitian. And if it's Hermitian, well, that means our parity operator is equal to the Hermitian conjugate. And now on to part B. This says, show that the eigenvalues of the parity operator are plus and minus 1. So let's just define parity equals some eigenvalue lambda times your original. So this is just an eigenequation. So now, with that defined, if we take parity acting twice on psi of x, well, we know what what that would give you. This first parity operator would make it so you'd have parity activating on psi of negative x. But then that other parity operator is going to act on it, and you're just going to get psi of x. So this is equal to just psi of x. Okay? But if we consider this eigendefinition, we can learn a little bit about this. So what this says, this, I should do a different color. This is lambda and our state psi of x. And we still have another parity operator out here. Okay, so we have parity, lambda, that's an eigenvalue, that can just come out, is equal to just psi of x. And then we just do it again right here. We know what that is. Lambda squared psi of x equals psi of x, or lambda squared equals 1, which means lambda can be plus or minus 1. Okay, so those are the eigenvalues of the parity operator, and they are plus or minus 1. So if that helped at all, please give a like and subscribe. I'm going to continue to upload videos. Thank you.